Before I get on with the update, I have some rather sad news to share. I was contacted by a member of RC Groups, someone who is a friend of Matt Mrdeza, and again, pardon me if I mispronounced the last name, but he let me know that Matt passed away suddenly several weeks ago. I didn't know Matt personally, but I did feel that I had some small connection with him by building this model from his plans. The person that let me know about Matt's passing said that apparently Matt was watching at least some of the build videos that I'm presenting. I wish he'd contacted me about it, but I don't believe he ever did. Anyway, from other comments, I think there are others out there that are building this model from Matt's plans. So keep Matt and his family in your thoughts and prayers as you build his airplane. All right, so in preparation for paint and primer and paint, I put the model together. I put all the pieces together, basically checking for fit and finish. I'd like to show you this whole thing in a 360-degree walk around, but really to do that easily, I need to do it outside and it's raining. Maybe I'll get a chance to do it before I do prime, but for now, this is as good as it's going to get. So a couple of things that I found. A couple of problems that I found. One, the control horn on the left aileron was fouling against the hinge gap cover. It's on the bottom. And I fixed that, and I'll show you that video here shortly. The other issue I have found is that the flaps and ailerons are not really in alignment with the wing. So when I tape the flap flush with the wing cord, and I tape the center between the flaps and the ailerons together, the left wing, the tip sticks up about, I'd say about 1/8 of an inch or so from the wing tip. When I do the right wing, again, taping flush, with the right wing tip, it goes down a little bit more. It goes down about, I don't know, 1/4 inch, maybe 5/16 of an inch. So yeah, notice that the right aileron is down, the left aileron is up. So that would be a pretty significant left roll. I would have to have, when I fly it, I would have to trim it out. So to fix it, I basically have three options. Well, I guess really 4 options. One is to do nothing. I do absolutely nothing, live with it, trim it out when I fly it, and just let it go. The other 3 options, one is non-destructive, trying to correct the shape of the flap and aileron, or just one, depending on how I go about it. But non-destructive is to induce a reverse twist in the control surface, and then I would end up having to heat the control surface to try to get it to hold that shape. I'd have to use heat from an oven for this, because remember, these control surfaces have been fiberglass with resin, so they're not going to want to change shape easily. And the only thing that I know that would, allow this control surface to move in shape would be to heat the resin up, soften it up, let it take a new shape, cool it down, and hope that works. So that would be a non-destructive way of doing it. Then the next way, if that didn't work, is more of a destructive way, and that is to basically make a big X in the control surface, twist it opposite direction, apply glue, and get it to hold its shape that way. And then the 4th option, which I really do not want to explore, is rebuilding the flap and the ailerons, or just one or both or all of them, I don't know. So that's what I'm looking at. So for now, let me go ahead and show you the fix I did for the aileron control horn. So A couple of days ago, I epoxied in all of my control horns. And this left aileron, I got the control horn a little too close to the leading edge of the aileron. So what's happening is the control horn is fouling against the hinge gap cover. And you might be able to see I started filing out a little bit of a slot to account for that. But I stopped because I thought, you know, I don't really want to do that, because the other side doesn't have this problem. It's just this side, which means these control horns are not really in the same position on each wing. So I want to try to remove this cleanly. So let me show you how I intend on trying to do that. To remove the control horn completely and then reposition it. So how do I want to do that is, and I've already kind of done it on this side, just really as a test to make sure I could do this before I continued on. But epoxy can be softened with heat. Even after it's fully cured, it can still be softened with heat. And so I'm trying to use that to my advantage. What I'm doing is heating the end of a box cutter blade and slicing away, cutting away the epoxy. I'm using this blade so that I can keep it flush against the control horn and try to keep this cut as small as possible. The cutting both sides is going to enlarge the hole more than the control horn, but I think I can work around that when it comes time to glue the control horn back in. So I'll show you kind of how I envision this to work. I will say right now, I've never done this before. I have used heat to loosen epoxy up, but I've never tried to heat a blade and cut out a G10 control horn before. So I'm kind of interested in seeing how this works. So I'll show you at the same time. Now I'm going to start the other side. This side hasn't been done yet. So I'm going to start with this one so you can see the full process. And you can kind of already see this white stuff, that's the epoxy. It does seem to do a pretty good job. Now, could I just take the blade without heating it up and try to cut it out? I don't know, I probably could. But I thought adding the heat would help, you know, to loosen the epoxy and make it just that much easier. All right, it's loose. Problem is, you know, I can't get to the front and the back edge. I'm gonna have to just try to carefully break it free if I can. Actually, I think it might just slide right on out now. All right, and the slot for the horn is still fairly clean. It is wider, but now I can open up the back, slide my control horn further back in the slot, and re-glue it in. So I cleaned out the slot and I elongated it a little bit more to the back, and I also sanded a little bit of the front and the rear control horn. It's not glued in right now, it's just being held in place with this toothpick. But that gives me, with the control horn touching the slot, that gives me 1 3/8 of an inch down aileron. And the right side, as it stands now, is also 1 3/8 inch. I'll have to go check the instructions, what they were calling for with the control throws for the ailerons. And checking the plan instructions, the designer was calling for 7/8 of an inch up. And that's roughly right about there, and only 1/2 an inch down. So 1 inch and 3/8 is going to be plenty. Again, the original wing has a full aileron, so being about 1/2 of that, I may need 1 inch, maybe 1 inch and 1/8 or something like that. That'd be my guess. But I think that gives me plenty. After taking the flap off of the left wing, I double checked it. I checked the trailing edge for straightness, and it is straight. It's very straight. And I checked the leading edge, and it's straight as well. But if you sight down along the flap itself, my finger's probably in the way, but there is a twist. It has developed a twist. And when you put it on something flat, you can see the twist. See how it rocks? So there is a definite twist that has been introduced somewhere along the way. I'm not sure where, but that's beside the point. So to fix this, I'm going to take a wedge and just stick it up underneath the root part of the flap. And I'm just going to then stick a bunch of weight, about 4 weights worth. And I ended up taking all 4 of the control surfaces off of the wing, both flaps, both ailerons, checked them, and each of them had a little bit of rocking action to them, so they're all twisted a little bit. I'm not sure why that is. I'm pretty sure I built these things straight, but that's beside the point. So I went ahead and I've clamped all 4 of them up. I'm using just a couple pieces of plywood to clamp them to, and it's got some cawls that protect the control surface from the clamp pressure, trying to prevent some indentations, and some wedges which help to square up the clamping pressure to the control surface. What's going on out there, Fatty? Huh? What's going on out there, huh? And I looked up on the internet, and it appears that most epoxies soften between 100 to 130 degrees Fahrenheit. Of course, you know, each epoxy is going to be a little bit different. But they say if you want to soften your epoxy in an oven, set it to a maximum of about 175 degrees Fahrenheit. So that's what I'll do. I'm not sure how long to keep it in. I guess that's just something I'm going to have to experiment with. I guess I'll start with about 30 minutes maybe. So I did a little research on the internet, and it seems that you can heat this resin up to about 175 degrees Fahrenheit. So I set my oven at 170 degrees. That's the lowest setting it would go. And I heat cycled all 4 of the controls. I placed them in the oven for 10 minutes, and then I put them in a refrigerator for 10 minutes. And I did that 3 times. And after doing that, put them back on the wing, and I really like the results. You can see as you go along the flap to the aileron and then out to the tip, well, there's very little sag in the tip, almost none. I mean, basically, this left wing is perfect, and considerably better than what it was before. The right wing did not turn out quite as well. Again, heat cycling 3 times, you get out to the aileron junction, it looks pretty good. But when you get out to the tip, well, it sags still a little bit. It's about 1/8 of an inch or so. And I looked at the aileron and it looked like it still had some twist in it. So I heat cycled this 3 more times for a total of 6 times. And tried it on with the wing each time. And it only improved it, marginally. So after that, I decided, well, I'll just live with what I have. But still, it looks a whole lot better than it did before. And in reality, when I fly this thing, there's going to be some in-flight trim changes, and that's going to change the way these controls are going to look. But again, overall, I'm pretty happy with the method, the technique. It looks a lot better, and I can go ahead and press on with painting now. And I have to give a big kudos to my friend who offered this suggestion. Something else that I want to correct is how I treated the top of the fin and the rudder. For some reason, I don't know why, I squared off the top of the fin and the rudder. The real aircraft has round tubing that goes all the way around like this. And so I rounded the front of the fin, I rounded the back of the rudder, but I don't know, I squared off the top. So anyway, I want to take care of that. Now the easy way would be to just take what I have here and round it over, and that would work for this. This is fiberglass, and so I could just round it over and then smooth it out. Maybe put some more fiberglass on it, and that'd be okay. However, the rudder is not so easy because it's coverall fabric. And I don't want to get all the fraying that I would get with that fabric if I try to sand a round over on the rudder. So that leaves me basically with just adding some balsa to the top and rounding it over. And it makes the rudder a little bit taller than scale, but hey, that's what happens. The rudder will be easy, the fin will be easy, except for this rounded part up here. I'm gonna have to probably, after I round over my balsa piece, add some filler or something to account for this round over. So I'm gonna go ahead and work on that. For starters, I glued on a piece of oversized balsa to the rudder. This just needs to be shaped and rounded over. And then for the fin, this was one long piece of balsa. I cut it at an angle, re-glued the cutoff piece back to the balsa, but not to the fin. This is basically has 2 purposes. One as a stop to know how far back for this top piece to fit, and also the inside here will be filled with epoxy microballoons, and this will act as somewhat of a dam, keeping that epoxy microballoons from running everywhere, hopefully. And so then I ran a bead of thick CA along the middle of the top of the fin and glued on this top piece. So now it's just time to mix up some epoxy microballoons and fill in here, and then do some sanding and shaping. So I've taped off the other side. I've got tape all across this area to create a dam. Now I'm just going to fill in with some epoxy microballoons. I'm using the Zap finishing resin for this because it's an easy mix and I only need a very small amount. So I can mix up 1/2 gram of part A, 1/2 gram of part B. And then I threw in some micro balloons. Again, the GoPro cut off on its own, so I believe I think I said 1/2 gram of part A, 1/2 gram of part B. Threw in some micro balloons, and now I'm just gonna try to fill in all the recess of this leading edge of the fin. And I think to really try to get this mix into all the little nooks and crannies, I'm going to add a little bit of heat after I apply this. I'm gonna let this cure overnight and come back to it tomorrow morning. The next morning after the epoxy had cured, tape was added to the fin and rudder to protect it while I was sanding the new balsa. The new balsa was block sanded to the outline shape. Then I went back and I rounded over the edges. Then I gave it 4 coats of a water-based sanding sealer. This fills the grain very well, and that way I don't have to add more fiberglass or coverall fabric to these new balsa pieces. Then I filled in the gap between the new balsa and the old fin and rudder with some spot putty, sanded it all down, gave it a couple coats of high build primer, and after sanding, you can't tell that I added this new addition. In the next video, we get to priming and final priming and hopefully some paint.